Hey man,
Hi.
we have another guest here.
Yeah,
It's
the day full of guests.
It's Stefan from far away. I would like him to introduce himself and tell us what's your name, what's your position, what's your company, and why people should pay attention to what we are going to speak about.
Yeah, sure. No, thank you for having me on the show. Great to be here. I'm Stefan Hrabar, one of the co-founders of Emerson. We are a company based in Australia, spun out of a research group in Australia focusing on robotics, SLAM, and using SLAM for navigation and for mapping. And we co-founded Emerson almost 8 years ago to commercialize some of the technology we've been developing, especially around drone autonomy using SLAM and LiDAR, and kind of grown the company from there. I'll leave it there, and then we can go into more details about what we do.
From the first site on the company and then on the product line, I was like amazed with the design. I know you're a design guy, so if you look at it, you can see that everything is just clicking.
Yeah, looking great. So.
Well, thank you. Yeah,
was that intention?
Of course. No, we've got a pretty good marketing team, and I also love design and pay particular attention to little details, and so does everybody else in our team. So no, yeah, it's.
How about the integration? Because I saw that you can basically take the same gadget and you can stack it on a hover, or you can use it on a drone, or you can use it on a vehicle. So how is that working? The integration?
Yeah, I guess if you're not familiar with our product, HoverMap is the product, and it's a LiDAR-based system that uses SLAM for real-time navigation, autonomous flight on drones and ground vehicles, and for mapping. And like you said, it can be used in many different ways. So from the beginning, it's always been designed as a system that can be plug and play different modalities. Because I've got a background in robotics and drone autonomy, that was kind of the focus from the beginning, is to make a system that can be used on a drone to navigate the drone without GPS, but then being able to take that off and use it as a SLAM-based handheld scanner, or put it on a backpack or on a vehicle or ground robot, to use different ways of capturing data. And I guess that's where we focus, is capturing data in challenging areas where there's no GPS or it's too dangerous to send people. So using that combination of robotics and autonomy with SLAM for mapping is a pretty powerful combination. Yeah.
Do you know where is your device used the most? Is it drone or ground, or as it's detachable, you don't know exactly?
We get some ideas. So depending on the application and the market vertical and use case. So for underground mining, if they want to go into places where it's too dangerous to send people, mostly on a drone, because that's the only way they can go in there, to fly the drone in. For scanning buildings, AEC, it's usually carried on a backpack or by hand. So it kind of depends on the use case. Yeah.
I was always wondering with these like multi-usage solutions, like, can you just go and scan with your hand some space, and then go and while scanning attach it to the drone and let the drone fly, and just without like
you can
termination of the scanning?
No, you definitely can, and we've done that. The only I guess limitation is the battery power for the system. So when it's on the drone, we use the drone's battery to power it, so it's connected to the drone battery. When it's used by a handheld or backpack, there's a separate battery that's powered. So if you wanted to switch between modes, you just have to make sure it's always connected to a battery source. Mm-hmm. So in that way, you have a separate battery on the drone, and you just disconnect that, take the whole thing. So yeah, there's definitely an advantage to do like one continuous scan, then you don't have to merge data. But our SLAM algorithm is very good at merging data. So for most customers, it's not a problem to take it off the drone, stop scanning, put it on the backpack. And then when we do the merge, it does a SLAM-based non-rigid merge. So it's as if you captured all the data together anyway. It doesn't really make a difference.
So do your clients usually rely on cloud-to-cloud merging? Or
no, it's in our software we do a non-rigid SLAM-based alignment. So we basically take two data sets, feed it into our SLAM pipeline, and it acts as if it's captured at the same time. So we find new loop closures between the two different SLAM data sets, and it does a non-rigid alignment as long as there's overlap between those data sets. So it's not just ICP cloud-to-cloud rigid, because if you've got a little bit of SLAM drift in each point cloud, you'll never get a perfect alignment. But if you use SLAM-based non-rigid, it corrects those differences in the point cloud. Yeah.
Mm-hmm. And we are in our section is always called like future in reality capturing,
Yeah.
and we are then asking everybody like, how do you look at the new stuff which is happening on the market? That means now everybody talks about Gaussian splatting,
Yeah.
combination with LiDAR. Is that a way you are looking at, or not yet?
I mean, it's an exciting space to see the advances in like the visualization of this reality capture data, making it more accessible and seeing like, yes, incredible detail from images and LiDAR. So I mean, it's a no-brainer. Doing combination of those two things makes sense. We are not yet doing our own sort of Gaussian splatting or anything like that. Our data has been fed into Gaussian splatting algorithms and engines, and it combines and it works, but we haven't brought that into our software yet. I guess we are focusing more on the survey end of the spectrum than the reality capture, where Gaussian splatting is great for visualization, but Gaussian splatting with images just by itself is not a great survey output. So eventually, I mean, those two areas are coming together, and I'm sure there's going to be industry standards, and everybody's going to be using Gaussian splatting or some variation of that for visualization, and you'll be able to take type of measurements from that. So I guess the benefits of our kind of system and others that are using LiDAR and imagery, you can do a better solution than just using imagery for Gaussian splatting. So you can use the LiDAR data as a prior and a depth prior for the Gaussian splatting. So eventually I think it makes sense that all of this is going to come together.
Yeah, it's exactly like how we see it, that it's not, we always say like it's not a replacement, it's just a layer on top, as you mentioned, this is a layer which help you to visualize the final data and help you to see something else than just from the point cloud, but keeping the point cloud underneath to be able to measure and do everything. So
yeah, definitely. And I mean, to me, it's not just imagery that's another layer. There's so many other sensor modalities that you can layer on top of the data. So we don't just work in survey and reality capture. We work in sort of search and rescue and military and defense, where they want to overlay gas information or radiation information onto the 3D data, ideally in real time. So if they're sending a robot into a mine where there's been an incident and there's poisonous gases, they want to be able to see that in real time. Where's it safe for a human to go? So then we overlaying 3D data and gas data, or if you've got a thermal camera, you can overlay that on. So it's just layering different types of information, but the underlying SLAM LiDAR 3D is kind of the skeleton, the backbone, and then you just keep layering these other sensor data on top of it.
So you have your own software and algorithm for processing. Is it then closed just for your scanners, or are you open, like if someone has some data and wants to process, for example?
Currently it's closed because the requirements for our SLAM pipeline are quite specific to our hardware. So the format of the data for the raw LiDAR data, the IMU data, the timing information, but we have processed others' data in with our SLAM pipeline, but it takes some manual adjusting of the pipeline. It is possible, but it's not something we offer at the moment. Others, you can use our desktop software Aura to visualize LiDAR data from anybody, just a LAS file, but you can't run our SLAM workflow on data from another SLAM device.
When I'm speaking to potential clients of SLAM technology, market is usually asking about the accuracy. So my like standard response is, most of the companies selling SLAM solutions are using like top 3 producers of the LiDAR.
Yeah.
So if we are speaking about the physical accuracy and the quality of the data that is being captured, it's always more or less the same. So you shouldn't be asking the question about the accuracy of the LiDAR. It differs with the algorithm, how you process the data, how you collect them, how you merge them, and everything else. But I remember the last year you were showing me your tests.
Yeah.
You were very eager to show me those because you were honestly very proud of them. So can you tell us like what was the results and have you done any updates?
Yeah. So I mean,
last year?
obviously, accuracy is a can of worms. Once you start talking about accuracy in SLAM-based systems, you can talk about relative and absolute accuracy, and if you're using control or not control, which sense the LiDAR sensor. But at the end of the day, so there was an event we participated in at GeoWeek almost 2 years ago now, where participants were invited to come to an environment like a conference hall like this, scan passageway around 300 meters long, and then some parts off to the side. They had set up a control network, and then we were all given, I think, an hour slot to capture data, process the data, submit the data to the organizers, and then they did some comparison and evaluation. So we participated in that. We ended up capturing it in 3 different ways. One was just walking around on the backpack, normal speed. Another one walking around slower with more loop closures. And then another one just for fun. We got our guy to run through the environment. And we did our own comparison between those 3 modalities. And I was really surprised with how little difference there was between the running. And the other thing was when that running scan was done, it was open loop. So I started one end of the passage, 300 meters later, stopped the scan, no global loop closure. Yeah. And the results for that were pretty much as good as the loop closure where you went there and back. So yeah, and for that, we also compared using so we have an option to use ground control points to improve the accuracy of the SLAM solution. It constrains SLAM. So we did a test with and without using the GCPs. And that showed that the GCPs over the distance definitely helped to improve the global accuracy. But even without the GCPs and with running through the environment, open loop still produced a very good result. We haven't done that exact same sort of comparison since then, but there have been other independent studies and others that have sort of used our data. We get feedback from others that are.
My educated guess would be that you're not suggesting your clients to run with the scanner.
No, unless they are trying to get the scan done very, very quickly. No. It's, but I mean, I guess it kind of proves that the robustness of our algorithm can handle higher speeds. I mean, our systems are used on vehicles, on drones, on ground robots. I've taken mine mountain biking, running down the trail. So it's not a system that you have to walk carefully like through the environment.
But there is this saying that just because something can be done, doesn't mean it shouldn't be done.
Yeah. I mean, obviously, you sacrifice the point density at speed. So yeah, it's.
So what is actually like a relevant speed limit up to which you are able to guarantee the good results? Yeah.
I mean, guarantee the result up to what level of certainty, I guess, is the question. I mean, just some proof points. When we have a system mounted on a vehicle and we scanning streets, we go at normal city driving speeds, 30, 40 kilometers per hour. No problem. And that's if you just use SLAM, obviously you'll get a good result locally. If you start traveling like multiple city blocks, you'll start getting some drift. That's when it helps to include the RTK GPS for corrections. And then, driving at those speeds when you've got RTK, there's no problem with SLAM. If you start driving at highway speeds, the biggest challenge you get is you'll start seeing gaps in the data because we're rotating the LiDAR, and as it sweeps, sometimes when you're traveling very fast, you'll get gaps in the data. But we've driven our system at highway speeds, and we still get a valid result. But you start getting gaps in the data.
Do you sell your own GNSS receiver for that, or you just support whichever?
Yeah, we support a couple of different brands, Emlid, Trimble, Leica, some of their different models. So we read in their live stream, log it in our file format, and then in the post-processing step, we combine SLAM and RTK, and we look at the accuracy of the RTK, and we weight how much we use that versus SLAM. So if you start outside when you've got RTK, and then walk inside when you lose GPS, then we only use SLAM, and then when you go back outside, we start combining SLAM and GPS. So we use an intelligent combination of SLAM and RTK.
And how does the averaging afterwards looks like? Just imagine walking into this space from outside using RTK, scanning this side, walking out from the other side, and again receiving the RTK data.
Yeah.
So there will be a drift, of course, because you will be getting different coordinations within your data set. So what's happening afterwards? How do you correct those data?
So you can think of RTK as basically thousands of GCPs. So each RTK reading is kind of like a constraint to the SLAM trajectory. So when you have RTK, we use that to constrain. And then in between, when you've got no RTK, it's just SLAM. And then when you come out the building and you get RTK again, it's like as if you had GCP out like at each end of the building. So yeah, I mean, that's kind of the best way to think about it. And the how much weighting we give to the RTK data depends on the number of satellites and the accuracy of the RTK data.
So after the validation of both spaces scanned with the RTK on, then you just like stretch or compress the data that are within it, so that it just
so what the SLAM algorithm is doing is estimating the trajectory. So where has that the origin of that sensor been in time as it's moving through space? So when you get GPS fixes, you use that to stretch the trajectory to match that, and then from the trajectory you project the LiDAR points out to create the point cloud. So it all starts with the trajectory, and then you project the LiDAR data to make the point cloud.
Oh, okay, I understand. So you are not actually stretching the point cloud because you are those points are reliable with some certain error, but are still reliable because you know the accuracy of the technology of the LiDAR.
Yeah.
So you need to just adjust the path it was walking because that is not that precise.
Yeah.
Okay.
I'm not the software engineer that does the coding. So
we are neither. So
this is my understanding of.
No, but that's perfectly fine because I'm not like deep in the tech myself. So I'm asking these like very basic questions so that also our audience can understand it better, because I don't consider all the audience like perfectly capable of understand how SLAM works, right? So
and it's the same when we use GCPs. So if you've put a GCP in the environment. We use that to constrain SLAM as well, and georeference and constrain. So when you see a target and we tell the SLAM algorithm this is the XYZ coordinate of that target, it can then use that to adjust the SLAM trajectory to, it's part of the optimization. So it bends the trajectory to make sure that if it's that part of the point cloud matches the coordinate that you've given it.
Mm-hmm.
Previously, we could only do that with kind of a reflective disk that our software would look for high intensity features, recognize that as a target. You feed it a CSV file with the known coordinates, and then we do a constellation match, and then it uses that to constrain the SLAM solution. Now with our latest released Aura 2.0, you can select anything in the environment. So if you've got a checkerboard or the corner of a table, you can, in the point cloud, you can select that as a GCP, provide the coordinates, and then it'll do the same thing.
Mm-hmm.
And you can use a mix of the automatic GCP targets and the manual ones. And then during the workflow, it gives you a preview of your registration errors. So you can tell if you've made some big mistake. You've selected the wrong target for that CSV. So you can, GCP, you can do a rough check, and then it does a rough alignment, and then we rerun the SLAM algorithm with all those constraints, produce the output, and then we allow you to select some of the targets as checkpoints. So they're not actually influencing the SLAM, they're just there as checkpoints, and then we generate an accuracy report. So for every GCP you get accuracy data, and for every checkpoint. So you can actually now validate that your SLAM result is within whatever tolerance you're looking for.
And does this software support a combination of the TLS data with your data?
No. I mean, you can load the data together and view it, but we're not doing anything to
merge them.
Yeah, no.
Okay.
Is there anything on your pipeline or like in the roadmap for the future? What you could share with us?
Sure. Well, I can't give everything away. So I mean, that example of TLS and SLAM, no, that's not currently on the pipeline. We've got some pretty exciting improvements coming with the precision of our data that we will be an option. So for most, obviously, SLAM solutions provide a point cloud. Some vendors do post-processing of that data to kind of smooth it and give it a cleaner look, but some customers like that, some don't, because it can end up rounding corners and losing some detail. So we believe that's something valuable for certain use cases. If you want a nice, thin cross section to trace a floor plan, it's very useful, but you don't want to round off the corners. So we'll do something where we give customers the option to turn that on or off and look at the data before and after smoothing, instead of just always turning it on and having it as a black box. So, because that's one of our philosophies, is to allow our users to customize our SLAM pipeline. They can get into the parameters, they can tweak things to make it better for certain types of situations and use cases on SLAM environments, instead of just making it a black box where you have to, hope that it works every time. What else? Yeah, I've got to be careful about what I say. 'Cause I can't,
Therefore, we are giving you a bit of space,
yeah. The more you keep quiet, the more I have to talk.
Yeah, this is the negotiation strategy.
Yeah. But no, I mean, I'm excited about what we've launched at, as part of this event. Like I said, the improvements in our Aura software with being able to use anything as a GCP. We've updated the way we do our license management, so now it's all software based instead of relying on a hardware dongle. So it's more flexible for our users to check out a license when they're in, wherever they are, etc. So improvements to the some of the workflows that we're doing as well, to making it quicker and easy to use.
Okay, so there is apparently something you don't want to tell us. So just please tell us
what it is.
Is it, no. Is it going to be news on the hardware side or software side?
Maybe.
Okay, perfect.
No, I mean, there's definitely something very excited that I'm excited about, but I can't talk about it
Okay.
yet.
We respect that.
Unfair enough.
Yeah. We'll look forward to talking about it sometime in the future.
Perfect. Of
Yeah.
course,
Great.
of course.
Yeah.
It was a great talk. Thank you very much for coming.
No, thank you.
Thank you
Appreciate
very
it.
much.
Yeah. Thank you.
Yeah.
Cheers.
Have a good day.
Yeah.